JDBC, JPA, ORM, Hibernate, Entity, Repository, Spring Data, spring-data-jpa, Transaction, Column, Persistence Context, JDBCTemplate, one-to-many. Stop! Enough! Is that your reaction after seeing this? You've come to the right place. Let's take a deep breath and start from the beginning. How do you even connect your Java app to database? You'll need to use JDBC-api. It's an API that manages connecting to the database, issuing queries and commands, and handling results set obtained from the database. To use a particular database management system, you'll need to use JDBC driver to mediate between JDBC and the database. Having done that, JDBC-api will expose various classes, methods, and interfaces for communicating with the database. Released as part of the JDK 1.1 in 1997, it's one of the earliest libraries developed for the Java language. Everything else, every other framework and library we will discuss further on, uses JDBC to talk to database. How do you use JDBC-api? The steps are: establish a connection, define a statement containing SQL to be run, execute statement against the database, get result set back as a result, and iterate over result set and transform it into Java objects. Here's an example of JDBC code that queries the messages table. You probably had a hard time spotting the query. That's because directly working with JDBC-api is Java at its worst. Our query is surrounded by code that creates a connection and forces us to catch checked exception, even though in most cases we can't address the problem and will only have to rethrow exception to be handled upstream. Then we need to create a statement and clean up afterwards. We would need to repeat the same boilerplate code for every operation against a relational database. The thing we are really interested in is what select should we execute and how do we map results to something we can use in our application. To add support for working with JDBC, Spring created a set of related dependencies that you can include in your application. JDBC-api Starter. To handle a ceremony of repeated tasks required to perform the actual job, concept of JDBC templates were introduced. More broadly, Spring uses templates design pattern in other cases as well, where there's a lot of housekeeping involved, like for example in REST template when consuming HTTP REST APIs. When working with JDBC template, code becomes much simpler than the raw JDBC. You aren't creating any statements or connections, and after the method is finished there isn't any cleanup or exception handling required. Only the code that focuses on performing a query and mapping of results is what's left. Let's get back to original JDBC code. Not long after JDBC was introduced, toolkit for working with database, Hibernate, was created. Hibernate was trying to address a couple of issues developers ran into when working with relational databases. To create Java objects from result set, you'd need to explicitly get each attribute. Is there a more declarative way that could be expressed? And once we get the objects, how do we circumvent the fact that in object-oriented world we have classes, objects, inheritance that produce object graphs, while in database we have tables and relationships. Although concepts have similarities, they also have structural and integrity differences, as well as differences in manipulation. To address the mismatch issue, commonly called impedance mismatch, object-relational mapping features were introduced, first by the way of XML configuration, and later programmers could use annotations to define how objects and relationships should be created from database entries. Annotations like entity, ID, one-to-many, etc. In the early 2000s, when this was happening, developers came to Java attracted by slogan "Write once, run anywhere." However, due to gaps in SQL spec and specific custom things database vendors included in their offerings, raw queries written in JDBC were not portable at all. Hibernate invented the solution of HQL, Hibernate Query Language. Instead of writing raw SQL that operates on tables, you would instead write neutral queries that operate on object graph ORM produced. Then Hibernate would translate that to SQL for a particular vendor based on what dialect and driver you were using. Lastly, since Java applications and database were on different server, each time you issued a JDBC statement, network round trip was happening to issue the statement and get the result back. Question was, could this somehow be batched? And since we already have objects in memory, do we really need to hit the database next time we need the data? To address the issue, Hibernate de facto created batching and caching layer called persistence context. To quote Phil Carlton, there are only two hard things in computer science: cache invalidation and naming things. Due to inherent problems with caching and to keep track of changes, persistence context introduced complexities in entity lifecycles that only one person in the world understands. Besides Hibernate, other vendors were also working on similar issues, and so a standard was coined that everyone should abide by. JPA, or Java Persistence API, recently moved and renamed to Jakarta package, so Jakarta Persistence API. Luckily, first letters are the same, so acronym was not changed. JPA. Concepts of JPA interface were heavily influenced by Hibernate, and to no surprise, Hibernate implemented the interface. Main annotations for object relational mapping transferred, like entity, column, one-to-many. Hibernate query language became Java Persistence Query Language, or JPQL, and other concepts were transferred as well, like session became entity manager. To support working with JPA specification, Spring team created spring-data-jpa starter, with Hibernate as default implementation. Spring Data is a large umbrella project comprising several sub-projects. Most of them are focused on data persistence with a variety of different database types. Not just relational, but also document like MongoDB, graph like Neo4j, or key value store like Redis. Key concept Spring Data brings is repository as an abstraction of a persistent store, term populated by Eric Evans in his seminal domain-driven design book, which is still relevant 20 years after its first release. To return to spring-data-jpa, after you annotated your class with JPA annotations, the way you use repositories in Spring Data is by extending one of its sub-interfaces or repository interface itself, and Spring automatically makes available general-purpose methods you would expect from an entity. In our case, by extending CRUD repository, we automatically have CRUD, create, update, read, delete methods available without writing a single line of implementation. Spring-data-jpa can do that for us because it can interpret JPA annotations which describe entity and attributes for an entity and construct appropriate SQL from that. If we have needs beyond basic persistence, Spring-data-jpa exposes miniature DSL, domain-specific language, where it parses method names and attempts to understand the method purpose in the context of persisted object, and generates SQL from that. That's sweet. Finally, let's talk about another member of Spring Data family related to relational database support, spring-data-jdbc. Just to point out, to avoid confusion, this is spring-data-jdbc, and the previous API with JDBCTemplate we were looking at was JDBC-api without the data. It's newcomer to the scene, being first released around 2017, and its purpose was to create something like spring-data-jpa, but simpler, as number of concepts you need to understand to work with JPA might be overwhelming. The questions like, when should I stop loading stuff? What am I saving? It solves by intentionally stripping features. For example, no caching, no lazy loading, no dirty tracking, no session. Entity gets saved when you call save. No JPA queries, just plain SQL, so you are forced to control what SQL your app runs, in contrast to JPA which creates and runs bunch of SQL for you. Spring-data-jdbc also extends on concepts from domain-driven design by introducing aggregate, as a cluster of domain objects treated as a single unit, and aggregate root as a reference to which change to aggregate should happen. So to recap, Spring's JDBCTemplate greatly simplifies working with JDBC. Spring-data-jpa and Spring-data-jdbc make working with relational data easy by exposing repository interface. What should you use? I'd recommend spring-data-jpa, which in general is most popular choice. By using Spring Data, you'll get access to repository abstraction, which gives you so much for free it's too good to pass up. If you come from database-heavy environments, you might go for JDBC support and handle SQL yourself. I don't recommend you use spring-data-jdbc unless you know what you're doing and try it out first. While it did succeed in its intention to be simpler than spring-data-jpa, it's also the youngest of the other two and not as battle-tested. It's mostly a one-man development effort that tries to force you to develop in a certain way, which I feel should not be responsibility of persistence framework. Hopefully that made things clear. Okay, you can breathe out now.